now we have come to 1.3.2, integration by parts. Suppose u and v are differentiable functions of x. By the product rule of differentiation, when we differentiate uv with respect to x, we get u dv dx plus v du dx. Let's put that as equation 1. So integrating both sides of equation 1 with respect to x, we get finally we get uv equals to the integration of u dv plus the integration of v du. So when we rearrange that, we get the integration of u dv on the left hand side, and which is equal to uv minus the integration of v du. So the idea is to choose u and dv so that the integration of v du is simpler than the integration of u dv. So that's why in the formula we can see that the original question becomes the integration of u dv, and then after doing the by parts, we get on the right hand side the integration of v du, because v du is simpler, so that we can integrate the integration of v du compared to the integration of u dv. Okay, now before we proceed with solving questions in example 8, there is a rule that we need to know so that we're not confused of which one to be let equal to u or which one to be let equal to dv. So normally we use LPAT, or we can say LOPAT. So L stands for log, P stands for polynomials, E stands for exponential, T stands for trigo. So let's say we have in the integral of u dv log and trigo, so we would choose log to become u and the trigonometric function to become dv. So that's the order of which one to be let equal to u. Okay, now let's try question 1. So in question 1, both are polynomials, but normally we take the one with less complicated or less power, so that we can reduce it and it has no more x. So in this case, we let u equal to x. Then if we differentiate u with respect to x, we get 1. So du is equal to dx, and so the other one becomes dv, which is x plus 1 to the power of 1 over 2. So if we differentiate dv, and on the right hand side we integrate with respect to dx, so on the left hand side we get v equal to x plus 1 to the power of 3 over 2 over 3 over 2, which gives us 2 over 3 times x plus 1 to the power of 3 over 2. And then putting them together in according to the formula, so we need to rewrite the original integral first. X times the square root of x plus 1 dx, which is equal to uv. So first we take u and v, we get u times 2 over 3 times x plus 1 to the power of 3 over 2 minus the integration of v du. So v is 2 over 3 times x plus 1 to the power of 3 over 2, and du is equal to dx. And then integrate that, so uv does not change, we just need to rearrange. 2 over 3x times x plus 1 to the power of 3 over 2, and then minus the integration of v du, which is 2 over 3 times 2 over 5 x plus 1 to the power of 5 over 2 plus c. And then rearrange everything. We get 2 over 3 times x plus 1 to the power of 3 over 2 bracket 3 over 5x minus 1 plus c. So now that's done for question 1. Now let's continue with question 2. So in question 2 we have ln x dx. It seems like ln x is alone by itself, but it's actually not. We can take u, so we let u equal to ln x based on the LPAT rule just now. Okay, so du dx is equal to 1 over x, so du is equal to 1 over x dx. And then we have dv equal to, we can say 1 dx. So integrate both sides. We get on the left hand side we get v, and on the right hand side we get x. And then rearrange that, okay, according to the formula. So we have uv, which is, we can put x ln x minus the integration of v du, which is x times 1 over x dx. So that gives us x ln x minus the integration of 1 dx. And then finally we have x ln x minus x plus.